In this quick video, I'll walk you through the solutions to the homework problems from last week. Now, problem number 8 was rather straightforward, so let's jump straight to problem number 9. Here we're having to do proofs in predicate logic, that is, proofs that are involving the quantifiers. So the first thing to do when looking at a problem is to look at what are your premises on the left side of the turnstile, and what is your conclusion that you're driving after on the right side of the turnstile. And you're always going to try to strategize about what to do by thinking about what your goal sentence is, and that's what you have on the right side here. As always, you list your premise as an assumption. Nothing about that changes when we move to predicate logic from propositional logic. Now, this proof is actually fairly straightforward. The premise really gives you everything you need to start straightforwardly building up the goal sentence, the conclusion. The biggest mistake to look out for here is the temptation to do this. This would get you the proof in one step, that is, if it worked. Here, what we've done is say, well, what we have is a universally quantified sentence, and what we want really is that same universally quantified sentence, except we want to insert in an existential quantifier in the middle. But you can't insert a quantifier into the middle of a statement like this. Anytime you introduce a quantifier, if you want to use one of the quantifier introduction rules, you've got to put it on the outside. So this move is actually wrong. What should you do instead? The first step is actually to take away the universal quantifier using the elimination of the universal rule. Why would I do that? That's kind of counterintuitive, right? We're starting with a universal quantifier, and we want that universal quantifier in our conclusion. So why would we go through the process of taking the universal quantifier out? Well, again, we have to think about the order of operations here. We want the universal quantifier on the outside, so it needs to be the last thing that's introduced. That means we're going to have to do a little reordering, and we're going to do that by first taking away the universal quantifier to get line 2 here, not RAB. Remember, the elimination of the universal quantifier is very, very straightforward. A universal quantifier tells us everything is like this, so anything we want to pick, any individual constant we'd like works. I chose B here. You could have chosen C, D, E. It really doesn't matter with the universal quantifier. Later on, we're going to reintroduce that universal quantifier, but again, we've got to do it in the right order. So the next thing to do is to introduce that existential quantifier. That gets everything in the right order. Make sure you bind the right variables to the right quantifiers. Like the elimination of the universal, the introduction of the existential is extremely straightforward. We have A as a witness to this, so we know that there's some witness, right? There is something such that not RXB. If A is not RAB, then there is something that is not RXB. Very, very straightforward. None of those provisos or restrictions to worry about in these two rules. Now the next step is to put that universal quantifier back on that we took off originally so that everything's in the right order, and we're done. That's a very simple, kind of straightforward proof. But remember, when you're using the introduction of the universal quantifier here, as we are in line 4, you've got to make sure that you haven't violated any of those restrictions or provisos. What were those restrictions? The first was that the individual constant that you're replacing with a variable in the universalization cannot occur in the sentence that results from substituting y, or a variable, in for the individual constant that you're dealing with. So let's take a look at this. In our case, we have a statement that we're trying to universally quantify. Let's call that phi b. It's this one here. There is an x such that not RXB. What we want to do is replace b with a variable. So phi y is the very same sentence with b replaced with the variable y. Now, if we want to add a universal quantifier to phi y, we have to make sure that the individual constant that we replaced with y doesn't appear anywhere else in the formula. So if we had, say, there is x not rxyb, then we could not proceed to universally quantify. Since there is no b remaining in this version with the free variable, we are allowed to then go in and put in the universal quantifier as we have done in the proof. So we checked the box for proviso number 1. Proviso number 2 is that b cannot be in any of the open assumptions, or the individual constant that you're dealing with cannot be in any open assumptions, cannot be at the top of a box that is still operative or not closed off at the stage of the proof where you're trying to do the universal generalization. And in this case, that's easy because there are no boxes here. We never made any open assumptions. Our only assumption here is one of the premises. And remember, premises don't have to be boxed off because we keep those assumptions with us as part of the proof. The whole point of this proof is assuming this premise, derive this conclusion. So we never discharge premises with boxes. No boxes, so trivially, proviso number 2 is checked off. Now we'll look at problem 10, which is a little bit more involved than the previous one, but it's still fairly simple and doable. So what's the process of thinking through a proof and figuring out how to do it? Well, you need to sit and stare at the premise and the conclusion and figure out, what do I have to work with and what am I working toward? So as always, the very first step is just to write a number 1 and write your premise, if any, as step number 1. Okay, now take a look at this and say, what can I do with this? Well, the only thing you could really do with this by itself is a universal elimination. So let's try that. See if it gets us anywhere. So I write down step 2, FA. I have an eraser handy because notice I've tried this and this doesn't really get me anywhere. I need a negation. I need a negated statement. And this doesn't really give me any materials to get a negated statement. So then I think, okay, that didn't really work. I'm going to erase it, but my efforts weren't totally worthless because I've illuminated something about what I need to do. I know now that I'm going to need to introduce some additional assumptions that I can then withdraw. So now I'm going to think to myself, okay, I need to introduce a negation. So I'll go and reference my introduction of negation rule. So what is the form of the introduction of negation rule? Notice I have to introduce an assumption and then derive a contradiction. That allows me to put a negation in front of the original assumption. Again, the kind of thinking behind this rule is, if you assume phi and that leads you to a contradiction, well then it can't be that phi. So we can then conclude that not phi must be the case. Now that I've reminded myself about how to introduce a negation, that gives me a clue. If I want this negated statement, my initial assumption needs to be this statement without the negation. So let's try that. Let's just write for all x, not fx, knowing that what we're going to try to do is derive a contradiction, and that will allow us to put a negation in front of that, and then we'd be done. So now I've got a little more to work with. So I look at what I've got, and I think, okay, what can I do? Well, once again, what I have in front of me are universally quantified statements. So all I can do now with what I've got in front of me is a universal elimination. But that might give me a little more traction now than it did prior. So let's try to do everything we can before we say introduce any new assumptions. Let's try to work with the assumptions we've already introduced. Now I'm in a better position to do the universal elimination that I tried before. Notice I tried this before and it didn't get anywhere, but now I'm in the context in which that might get me somewhere, because notice the elimination of the universal on line 1 gets me FA. What would the elimination of the universal on line 2 get me? It would get me not FA. Now that actually gets me somewhere, because what I wanted was a contradiction. Remember, I'm trying to use the introduction of negation rule, which means I need to get a falsum. How do I get a falsum? That's where my elimination of negation rule comes in. Notice, if I have phi on one line and not phi on another line, that allows me to write the falsum sign on a new line. Well, that's precisely what I have on line 3 and 4. I have FA and then I have not FA. So now I know that I can write falsum using the elimination of negation rule. Thinking back to the introduction of negation rule, that's exactly what I needed. I needed an assumption that would lead to a falsum. That's what I've accomplished. So now I can box off that initial assumption because I'm done with it. I'm using the introduction of negation rule to discharge that assumption, and I'm sticking a negation right in front of the statement that was the assumption. That's what I'm after. So the proof is done. That's the process of starting from scratch and trying to creatively think about how I can go through the steps to get where I'm trying to go. Now, another important thing, as I mentioned last week, was if I have the solution in front of me, how do I decode that? How do I get anything out of it? Well, again, if you're looking at the solution and trying to go reverse engineer the proof, go the other direction, look at the assumptions that are made that are not premises and try to explain to yourself what net benefit comes about from making that assumption. Since we just went through this in the other direction, we know, but what I would do if I hadn't done this proof, I had gotten stuck and then I'd gone and looked at the solution, I would say, here's the premise that they're going to withdraw. Here's the assumption that they're going to withdraw. I'll go and see where they withdraw it, see what they get out of it, and what rule they were using. Now I understand they were trying to use the introduction of negation rule here. And the way the introduction of negation rule works is to have an assumption that leads to contradiction and then stick a negation in front of the original contradiction. So now I know why they introduced this proof, and now I can see, I can make sense of what they're doing inside the box. What are they doing inside the box? Everything they can to get a contradiction with what they have to work with.